hopefully you did well on your quiz. It was a challenging quiz that we took yesterday. My class in here did fairly well with it, though. You know, some things I think as they looked it over, thinking, okay, man, I gotta make sure I don't mess that up on the next test, right? And that's really what you take away from quizzes and any homework as we go over it, is making sure we learn from those things. We're going to take a look at the homework now, though, page 442 in your textbooks, number 16 through 22, the even, so only 4 problems for homework last night. One of the shorter homework assignments you've ever had in this class. Don't get used to it. All right. Did you want to take vocab, or I think it was a grammar quiz as well? Vocab first. All right. So on number 16, we've got a multiplication problem. And with multiplication, your key is to first do what everywhere you can? Gavin? Factor up everything you possibly can. So on number 16, that numerator should be factored into x positive y, x negative y. That denominator doesn't factor necessarily, but Gavin, y minus x just looks funny, right? What should we do here?
Negative x plus y.
Okay, change the signs, or flip it around, make it negative x positive y, but then factor, and I'm okay with you, by the way, going straight to the negative coming out and getting negative x minus y. So they give you y minus x. You could go in between and say negative x positive y, but I'm okay with you going straight to this, negative x negative y. Either way, it's fine, just don't forget the negative exists. All right, then we come over here, x positive y, of course, can't do anything with that, so if it doesn't factor, class, just group it. And then down in that denominator, Gavin,
X positive y, x positive y.
All right, once we've got all of that, now what?
You get cancel.
All right, what cancels?
X negative y and the x positive y.
So what's left?
Negative 1.
Good. Not just a 1, but a negative 1. Remember, when everything cancels, it's 1, but we did still have the negative. The book would contend you would need to specify, because we canceled here, x can't be y. Because it canceled here, x can't be negative y. Or you could simply say x can't be positive negative y. However, there's not any x's or y's left in the answer, so what are we talking about anyway? But again, with the textbook, they would indicate this as well. How many had negative 1 for your answer on number 16? Questions on 16. All right, Brecken, let's go to you on number 18. And it's a division problem, right? But we never really divide, right, Brecken? We would... Right, so we're going to change this to a multiplication problem. We're going to multiply by the reciprocal. But taking that first fraction first, Brecken, that numerator, x to the 4th minus 1. How would I factor that? Good. Initially, x squared plus 1, x squared minus 1. But then the x squared minus 1, Brecken recognizes another difference of squares factors in x plus 1, x minus 1. So 3 binomials here. That first denominator, Brecken, simply factors into good. Then we're going to take that second fraction, we're going to flip it. And in each, the numerator and denominator, including when we flip it, I see 4 terms. So I need to think factoring by grouping. Now, for sake of ease, I'm going to go ahead and rewrite what we have. I normally would try to do it in my head, but grouping is a little harder to do in the head. So I'm going to take the extra step of writing the old denominator as the numerator, the old numerator as the denominator. And now, Brecken, let's go ahead and do the factoring. Well, what comes out in the first group? Good, and it is because of this negative that changes this to a positive y, and because of this negative changes this to a negative 4, which is perfect, because now what's common? Which leaves us with, and then down here, good. Remember in grouping, if there isn't anything, just make it a 1 and leave. And now we can clearly see the common, which leaves us within parentheses. All right, so the hard part is done. All that factoring is done. All the flipping stuff is done. Now what? So what's our answer? All right, now we do have some excluded values. We should say x can't be 2 except there isn't any x's left. We would say x can't be 1, but there aren't any x's left. We could say x can't be negative 1, but there aren't any x's left. X squared could never equal a negative 1 anyway. Agreed? Something squared is always positive, so we don't even have to worry about that. But this used to be a denominator, and it's now a numerator. So Brecken, we do have to say that y cannot be equal to 4. And there's our answer. How many had this? For number 18. Had this for 18. Okay, only Noah. Questions on this now. A little bit more of a challenging problem with all that grouping, right? Let's take a look at number 20. And this problem is somewhat infuriating as we work it. It's a subtraction problem, Maddie. And we know we never really subtract in algebra. Rather, we would add the inverse. So we need to kind of keep that thought in the back of our mind. We also need to remember, Maddie, you can't subtract or add the inverse with fractions until you have a common denominator. And we can't figure out the common denominator unless we first factor. So as we look at those denominators, the first numerator is seemingly benign, a nice easy 6, and but the denominator needs to be factored into. All right, and then we're subtracting, make a little note of that. Our numerator, again, rather benign, a simple little negative 4, but the denominator is going to factor by grouping here to get what? And then we're going to finish the factoring. Now there are a couple thoughts that I have here. Before I even go any further, I do see a negative. Maddie, would you like to just go ahead and cancel them up front, not worry about them? I think that's a good strategy to use here. And just, now we're done with the whole negative issue. We don't even have to worry about it. We should go ahead and draw our long line. And what goes under the long line, Maddie? Actually, this problem's not nearly as bad as I at first thought it would be. Yeah, really not too bad at all, because here all I have to do is multiply top and bottom by a plus b. Of course, the bottom's already been done, but in the top, I'm going to get, and here I just need to multiply top and bottom by, and when I do, I get nothing combines, nothing's going to factor, so nothing cancels. So it's a big, ugly answer, but it is at least correct. And how many had this for number 20? All right, only Brecken. All right, questions from the rest of you. All right, Maddie, you did a fantastic job with it just now. What was the struggle over the weekend as you worked? Okay, so just, did you put x negative 4 or x negative 3? Do you see it in your work? Or did you do it in your head? It wouldn't hurt to go and just write it down real quick, just to make sure we do it correctly. And then number 22, another addition problem, Noah, where once again, with all of our denominators, we should either factor or group them if they're polynomials, right? Monomials we wouldn't have to worry about, but they are polynomials. So that first denominator should be factored up. And the last one is just an ordinary x positive 1, right? We'll just group that. We do not, fortunately, need to worry about factoring or grouping numerators. Just leave numerators as they are. We really don't care about them. It's denominators that get our full focus. So Noah, as we draw our big long line, what's going to go under the big long line?
X negative 1, x positive 1.
And so here we need to multiply top and bottom by technically 1. Really nothing. We don't need to worry about it, right? Just copy down.
2x squared plus 3x.
Yeah, nothing changed. Here we need to multiply top and bottom by x negative 1. And that gives us
5x squared negative 5x.
We're not done this time because unlike the previous problem Maddie had, here we can actually combine to get
3x squared,
7x squared, there we go. That's a negative 5x.
negative 2x, and negative 4.
There we go. I don't know if that'll factor or not. I kind of think it won't, but let me just take a stab at it real quick. We know, Noah, that if it's going to factor, the 7x squared has to split up 7x and 1x, correct? And we know the signs are going to be negative and positive. But in order for anything to cancel, what number has to be with the x? It's got to be a 1, right? It could be positive or negative, but it would have to be a 1, which means this number would have to be a 4. Does the outer inner give you a negative 2x or even a positive 2x, or we could just change the signs? No, it's a 3x. It doesn't quite work out, so we don't have to worry about factoring. There's our answer. And how many had this? 4, number 22. Okay, a couple of you that time. Questions from those who did not. All right, so kind of a mixed bag. How many got, anyone get half of them? You got 2 of 4. Got 2 of 4. Okay, all of you got at least 2 right. Anyone 3 right? Okay, it felt like we kept alternating who was getting ones right here. Questions on these? Questions on these? All right, well, let's take a look at some word problems together now. And let's see here if, Maddie, if you'll read this problem out loud for us. All right, at your seats, go ahead and set it up and solve. Got it? Reckon as the rest of the class finishes, how many unknowns did you have? What were they? Good, the numerator and the denominator. Which one did you choose to be x, Brecken? Sorry? Numerator. How did you represent your denominator? So literally, Brecken, what's your fraction? And so if it says that the value of this fraction is 3/5, we would set up what equation? There we go. And what we have set up is a class proportion. Thank you, Brecken. So class, we should cross multiply. Brecken, when you did, you got? And let's do a double switch here. Let's bring the 5x over as a, to get, and send the 9 over as a, to get 9. So if x is 9, then my numerator is 9. And my denominator would be twice that less 3. 15 is the value of this 3/5. Yes, it is, and it checks out. How many had 9/15 for your answer? Excellent. Questions at all? Let's do one more. Once again, Brecken's first. Noah right behind him. Noah, we'll go to you this time. Says the denominator of a certain fraction is 7 more than twice the numerator. So once again, you have two unknowns, I believe, numerator and denominator. Is that correct?
Yes.
Once again, which one got to be x?
Numerator.
Numerator. How did you represent your denominator?
2x plus 7.
And so literally your fraction is...
X over 2x plus 7.
Right. However, it doesn't say that my fraction equals a third. It says if I do something to my fraction, it will equal 1/3. What do I have to do to my fraction?
Add 2 and numerator.
Good. Add 2 to the numerator to get x plus 2, and add 2 to the denominator to get...
2x plus 9.
And when I do that, now it's going to equal
1/3.
1/3. How many have this proportion as your equation? All right, so we cross multiply to get
2x plus 9 equals 3x plus 6.
Good. 2x plus 9 equals 3x plus 6. And let's do a double switch once again. Send the 2x over as a negative to get
X plus 6.
x, and bring the 6 over as a negative to get
3.
So, what's your numerator?
5 over 5.
What's your numerator?
3.
3. And what's your denominator? 13. Now, we're looking at that saying, but Mr. Tedeschi, that doesn't equal 1/3. I know. I never said it was going to equal 1/3. I said if you added 2 to both terms, well then it would be a
5
over
15.
and would that equal 1/3? Yeah, 5/15 would, but the actual fraction 3/13 does not. But this is your answer, 3/13. Somebody had this answer there on your paper. All right, you two did. You had the 5/15. Okay, again, not the original fraction, the messed with fraction. Did you do the same thing, Noah? Did you have the 5/15? What was your problem?
Well, I just answered and subtracted it by 2 since you added that, which I don't know why, because that just puts it back again. But
All right, questions? All right, well, go ahead and open up your notes to a new section. If you would also get some graph paper out. You would also get some graph paper out. And we're going to start a new section, changing gears here. Want to talk about graphing. Graphing. So there's the next section in your notes. Graphing. And you did a little bit with graphing when you were in junior high. You talked about bar graphs and line graphs and circle graphs and histograms and pictographs. You remember all that stuff from the good old days when life was simpler? And, well, we're not going to do all kinds of different graphs, but if anything, we would be looking at something similar to a line graph, except we're not going to be going all over the place with the line graph. Like you talked about the curved line graph and the broken line graph and the straight line graph. What we're going to be doing with is similar to what would be a straight line graph. Okay? So with graphing, I want to introduce you to this idea. You see this over here. You see a couple of crisscrossing lines. Now, when you were in junior high, all you ever dealt with were these two lines. A line that went out this way and a line that went up this way, right? And you kind of have your scale going off this way and a scale going up that way. Well, really, these two lines are simply number lines. Right, we're familiar with the number line. We've seen this already, right? Starts as 0 at the middle, right? Called the origin of the number line. And it goes all the way to, what would be way out there, class? Infinity.
Yep.
And beyond. Just kidding, you can't go beyond infinity. Contrary to what Toy Story would tell you. Right, so it starts at the origin of 0, and it goes positive 1, 2, 3, 4, 5, 6, 7. It just keeps going bigger, bigger, bigger to infinity. But we know this, you could also go negatively, couldn't you? Negative 1, negative 2, negative 3, all the way down there to negative infinity. We could do the same thing with another number line that goes up, starting at 0 and going up to infinity. Good guess. It was either positive or negative, right? An infinity upward, and of course downward to negative infinity. Make sense? So these two number lines, if you write these terms in your notes, these two number lines are called axes. Axes. Each one is an axis, singular, okay, like the Axis powers. But anyway, each one, or like the Earth revolves on its axis, which is not a real thing, by the way, so it's an imaginary concept. But anyway, axes, okay? The horizontal one, the normal, traditional, ordinary number line is called the x-axis. The x-axis is your horizontal number line. This is the number line we're used to working with, right? And the vertical number line that runs perpendicular to it is called the y-axis. The y-axis. So we have two key variables we'll use in algebra, x and y. You'll notice on this little graph grid thing here that there are arrowheads at the ends of the axes. That's because they keep going and going and going. You can't draw it infinitely. The idea of the arrow is just to indicate it just would keep on going. You also notice here that I've labeled this as the x-axis, this is the y-axis. Now normally, you wouldn't have to label quite that much. Normally, as you draw a graph grid, you put the arrowheads at the ends, and you simply put an x here and a y here, indicating x-axis, y-axis. Reason for this is there are other graphing forms besides what we call Cartesian graphing that look the same, but they don't use x and y. They use other axis labels. So we'll label it to indicate we're using what we call Cartesian graphing. Now, we'll get to that term in just a moment. This point right here is the 0 or the origin of the x-axis, and it's the 0 or the origin of the y-axis. They cross each other at their 0 points. That point then is called the origin. The origin. Same term for 0 on a number line, so it makes sense since it's the 0 on both number lines, or the origin of both number lines, it would be the origin of this graph grid looking thing. Now, the guy who came up with this graphing system, or the guy who's credited with it, there were a couple of guys working on it, is a guy by the name of René Descartes. Okay, you don't necessarily have to know his name, but you do need to know this term, Cartesian. It's named in his honor, René Descartes. Cartesian, they've made it an adjective. Cartesian graphing. Cartesian graphing. This thing then with the x and y axis is called the Cartesian plane. Plane, P-L-A-N-E, meaning a flat surface. The Cartesian plane is what we would graph on. So when you set up a Cartesian plane on graph paper, you set up two perpendicular axes that cross each other at their origins. This is also sometimes called the coordinate plane. We'll get to that term in just a moment. Also called the coordinate plane. The reason I like to teach you multiple terms is so no matter what math text you end up using, maybe in college, if heaven forbid you were to have to transfer schools and learn under another teacher, if they use the term coordinate plane, you're not like, what is the coordinate plane? I've never heard of this before. Yes, you have. We just called it the Cartesian plane, okay? So if you hear coordinate plane, it's the same thing, okay? Now, the reason it's called the coordinate plane is because on this Cartesian plane, every single point you could possibly plot has a particular value. Okay, for instance, as you're going along the number line, here's your x-axis, here's your 0, -1, -2, -3, -4, -5. This has an x value. It lines up with the -5 on the x-axis. In fact, any point I were to put right here would have an x value of -5. Does that make sense? The x value of a point is referred to as the abscissa. Now there's a silent C, it's the SC combining, so it's spelled abscissa, okay, but here in the month of February we don't want to encourage anything. So abscissa is how it's pronounced, but so there is that C in there just for spelling purposes, since we hate losing points for spelling, right? Minus a point for spelling is just annoying, especially when it would have been 100 and now it's a 99, or it would have been a 90 and now it's an 89. Right? Like, man, I should have had the A, oh, I should have been perfect. So abscissa with the C in there. And any point that I were to put along here has the same abscissa of -5. Any point I were to put along here, class, would have an abscissa of +3, right? That's what the abscissa of all those different points would be. Well, y values also have a certain name. And let's just say this has a y value of 5, like all these other points would. Okay, so this has a y value of 5. Well, the y value is called the ordinate. The ordinate. That's the y value of the point. So the x value, class, is called the abscissa. Thank you, Noah. Class, the x value is called the abscissa, and the y value is called the ordinate. Okay, now, how many of you noticed that when I put up these little tick marks, the tick marks right here are different sizes than the tick marks here, which are different sizes than the tick marks here? That's why you use graph paper, okay? Because graph paper is going to keep you from screwing that up, okay? But anyway, but yeah, the abscissa and the ordinate. Well, what that means is I can get an exact location of that point. See, there's a whole lot of points that have an abscissa of -5. There are a whole lot of points that have an ordinate of 5. But this is the only point that has an abscissa of -5 and an ordinate of 5. Does that make sense? If you know the exact x value and exact y value, then you know exactly where the point is. For instance, if I said, let's call this row 1, row 2, and row 3. Well, where would be row 2, seat 3? Right behind the camera, right? If I just said, where is the seat in row 2? Well, there's a whole bunch of them, right? But when I narrow it down by row and by row this way and seat number, that kind of narrows it down, doesn't it? Same way with this. So this is the exact location when you put the abscissa and the ordinate together. Putting them together gives us something we call the coordinates of the point. The coordinates of the point. And because every single point has its own set of coordinates, that's why this is called the coordinate plane. Okay, so the coordinates of a point are the abscissa and ordinate together. In this order, x, then y. Alphabetical still. So the x value we said was -5. The y value we said was 5. We'll put them together separated by a comma in parentheses. And that gives us the coordinates of the point. Now, if you've watched any sort of war movie, I'm sure you've heard that term. What are your coordinates or something? Or maybe a navigational term. Maybe there's been a flight or something on a movie you've seen. How many are familiar with that term, coordinates? You know. Okay. For instance, you've done this with latitude and longitude, right? In geography. Okay, what country is located at 20 degrees north latitude and 58 degrees west longitude or something like that? You know, right? Did you try to find it on the map, you use the equator, that's 0 latitude, right? And prime meridian, 0 longitude. All these things from last semester coming back to you? Yeah? All right. But anyway, coordinates. That is a very similar idea. It's just telling the x value and the y value. So if I were to pick this point here, what would be the abscissa of that point, class? 3. That's the x value. What's the ordinate of the point? -2. So the coordinates would be 3, -2. Make sense? Just put the abscissa with the ordinate to get the coordinates. Now, the Cartesian plane is divided into 4 sections. Notice that this first section here, all the abscissas will be positive, all the ordinates will be positive. This is the main section, if you will, because everything's positive. And let's face it, given the choice, we would always rather deal with positive numbers, would we not? So this is what I call the main section. Each section is referred to as a quadrant. A quadrant. There are 4 of them. Quad means 4. Quadrant refers to 4 sections of the Cartesian plane. This would be quadrant 1. It's the main quadrant. An x value that is negative, like we see here, with still a positive y value, puts us in quadrant 2. Down here, everything's negative. Anyone know a person who feels like a quadrant 3 person? Everything's just always negative. Gavin's like nodding his head. All right, quadrant 3, everything's negative. Quadrant 4, there's a little ray of sunlight again. The x's are at least positive, though the y's are certainly negative. I want you to notice the pattern here. Quadrant 1, 2, 3, 4 in this order. It makes the big letter C for Cartesian or for coordinate, or just because it happens to go in that order. All right, however you want to remember it, quadrant 1 starts here. So it's not what we might normally think. We might think, well, 1, 2, 3, 4, right? Going in order. No, starts here. 1, 2, 3, 4. Questions on the quadrants present. And of course, you see that information over here as well. The 4 quadrants. Here, where of course quadrant 1, x and y both positive, negative x, positive y, both negative, and then positive x, negative y there. Questions at all on the basic terms related to graphing here? A lot more terms than usual, right? So for instance, math quizzes, math tests don't normally have a whole lot of terms. Well, guess what this section is going to have? A lot of terms that you need to memorize so you can answer them correctly on quizzes that may be upcoming in the near future. All right, that said, let's practice plotting points now. So if you would, go ahead and get out a sheet of graph paper. And if you would, go ahead and draw an x-axis that's about, 15 boxes long or so. About 15 or so boxes long. Okay, so if you're using a ruler or something to help you draw a really straight line, you'd want to make it about, let's see, typical graph paper's 4 inches to or 4 squares to an inch. So maybe about 4-inch long line. And so go ahead and draw an x-axis that is about, 4 inches long or so. Make sure you put arrowheads at the ends of it. And then if you would, at the positive infinity end, put the letter x. We don't have to label both ends, just the positive end of the axis. Then try to locate about where the middle of your axis is. We'll consider that the origin, and we'll put a perpendicular axis straight through. Again, arrowheads at the end, and then a y up at the top or the positive end of the axis. Again, a ruler will help you, or some type of straight edge, maybe the bottom edge of a protractor, if you still have one of those from past years. We won't need the angle markings on the protractor necessarily, but a ruler certainly would help. Now, here's the deal. Some people, when they do the graph, watch, don't do this, they'll put 1, 2, 3, 4, 5, like that. You know me. What am I, class? Lazy. I knew that. But for me to be like, let's see, 6, 12. The problem is that's going to be really hard to read well also, correct? Like there's a fine line. Like marking every single one just is too much work. I'm too lazy. But marking like every 6, just, where's 5? What's 1 more 4, 6? Where's 3? It's right in the middle. It's a little bit harder to recognize. So I have found that the best way to do this, to make it work for a lazy person like me, is if I label every 3 boxes. So here's 0, 1, 2, 3. 2 is right before 3, 1 is right after 0. So if I were to label as 6, well, 4 is after 3, 5 is before 6. So every point has a reference right before or after it. And this is the least amount of writing while still being the easiest to read. Okay, so this is my sweet spot, is labeling every 3. So label every 3 positively below your x-axis. You might get out as far as 6, maybe as far as 9. All right, then do the same thing going backwards. Again, the 0 is right here. So then this would be -1, -2, -3, -4, -5, -6. And if you have opportunity, going out to maybe the -9. So go and label those. Again, remember, you don't count 1 at the origin. You count 0 at the origin, then -1, then -2, then -3. And anytime you draw a number line, you'll always put numbers below the number line. With the y-axis, here's my thing. I keep my first quadrant clear, completely empty, because that's where most of my graphing hopefully will take place. So when I label my y-axis, I'm going to label to the left-hand side to keep that first quadrant empty. So I'm starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course going down as well. And this is how you'll set up every Cartesian plane you do in class. Go and go negatively as well. You'll put your arrowheads, you'll put your x and y axes, you'll put your increments on there. Every Cartesian plane that we do. Make sure we put a little arrowhead up there, even though you kind of technically ran out of room. Hopefully that doesn't come back to bite you. It might a little bit. All right. So let's practice plotting some points. Let's suppose I have a point A that has coordinates of 3, 2. To plot, we're going to start at the beginning, right? It's a very good place to start. So I've been told by a reliable authority, whatever her name was on that Sound of Music thing. Anyway, start at 0, the origin, right? Then from here, you're going to go in the x, 3. Then you're going to go in the y, 2. Put your dot and a capital A next to it to label that point as point A. Make sense? So origin, track x, track y. How about this? For point B, let's go to 3, -2. Well, class, we begin at the origin. We track over to +3, but now we're going to go down -2. So point B winds up not in the first quadrant, class, but in the 4th quadrant. Letter C, -5, -1. It's a very negative personality. Do we have anybody in here with a C? Cross. All right. Anyway, so -5, -1. Again, starting at the origin, but class, we're going to go backward because it's -5. And then we're going to go downward, -1. And there's point C. Getting a feel for how to plot points. All right. Point D is the point 1, 4. Do this one on your own. 1, 4. Let's see if you can get it. I think you can. Did you put it up here in the first quadrant? Over 1, up 4. How about point E? 6, 0. Well, we start class at the origin. We go over
0.
No, 6. We go over 6, then we go up nothing. So we're going to stay on the x-axis. Over 6, but up nothing. Make sense? How about, though, if we had the point F is 0, -3. Again, we start at the origin. We go over nothing. We simply go down 3. And so point F ends up on the negative y-axis. Questions on this? Seem to be pretty straightforward. Set up a new Cartesian plane. Set up a new Cartesian plane on your paper. Usually, by the way, on one sheet of paper, you should be able to fit 4 Cartesian planes. So if you were to picture your paper being divided down the middle, and then down the middle across, you should be able to fit a Cartesian plane in each section, okay? So don't put the Cartesian plane in the middle of the page. You want to put it on one side top or side bottom, so that way you have plenty of room to set up your Cartesian plane. And that way you get more per sheet of graph paper, which saves trees, which absorbs CO2, which saves the environment. We won't all die in 12 years. I don't sound very sincere, do I?
No.
Oh, no. Okay, let's try this. It saves graph paper, which saves money, which makes your parents happy. Is that better? So set up your Cartesian plane. I have 5 points that I'm going to want you to plot on the Cartesian plane. We're going to have a point G, I have a point A, I have a point V, I have a point I, I'm going to have a point N. So if you would, at your seats, go ahead and graph Gavin. He didn't even realize what was going on. Everyone's turning around looking at him. He's like, oh. Well, that's what's happening here. Just picking on you, Gavin. Of course, because of child protection laws, we're careful not to show what our students look like on video, but we have now revealed what Gavin looks like on video. So if you've been wondering what he looks like, there we go. There's Gavin. That said, I don't really pick on Gavin that much, right? So perhaps if people were watching on YouTube, they might be more curious about the person who gets picked on the most. So once you've got Gavin graphed, go and set up a new graph grid number 3 for the day. We're going to graph Brecken as we close out the hour. We're going to go ahead and graph Brecken as we close out the hour. Actually, you may be able to use the same graph grid. Nope, because there's 2 point I's and 2 point N's. Nope, can't do it. I'd have different graph grids. You can't have 2 I's and 2 N's on the same grid. All right, how many had Gavin plotted correctly, first of all? Everything was perfect when you graphed Gavin. Any questions on graphing Gavin? All right, graph Brecken. I'm going to cheat and just erase Gavin. And there's Brecken. He looks a little more scattered than Gavin, doesn't he? Take a moment to finish that up. Your homework tonight has nothing whatsoever to do with graphing, though we will resume this tomorrow. Homework is just a little bit more fraction review. So once you finish graphing Brecken, go ahead and copy down the homework assignment, and then you'll be dismissed.